Hi, I'm Billy Connolly, Vermont Organics Market Manager for Vanguard Renewables. I work with our partners to bring commercial food waste and beverage waste here to our co-digester at the Goodrich Farm in Salisbury, where we convert food waste and manure into renewable natural gas. Today, I'm going to give you an inside look into how we do that. Come on along. Here we are at the Hydrolyzer tank. I'm standing right now above the 264,000 gallons of food waste. That material comes in the form of liquid and slurry and gets deposited and pumped in through hoses. We also accept more solid material. That comes in through the solids hatch. There's two deck-mounted agitators here, and those push the food waste material around. The residency time for the food waste is about 5 days before it then gets pumped from the hydrolyzer into the anaerobic digester, where it gets mixed with the manure to generate methane that becomes renewable natural gas. Here we are at the anaerobic digester. This is where the magic happens. There's actually 2 digester tanks here, and each is about 1 million gallons. The manure and the food waste get combined in here with the gut flora from the cows that consumes that material and generates methane, which is a very potent gas that gets captured in the headspace in these membranes, and that is the renewable natural gas that will be refined and then sent into the pipeline and down the line to the customers. Behind me is the CHP, the Combined Heat and Power System. We're completely off the grid here. This 800 kilowatt system generates enough power for this entire facility and also for the farm family. The heating system here generates enough heat to keep the hydrolyzer tank and all the material in it, as well as the digesters, at between 100 and 102 degrees, which is the optimal temperature for the methanogens, the microbiology that generates the methane. Here we are at the Manure Separator section of the project. We're just steps away from the dairy barn. And here is where the manure gets separated. The liquid goes in one direction to our anaerobic digester, and the solids get separated out and used for animal bedding. And this is a more natural form of animal bedding. It's not synthetic, it's not sand, so the cows love it. And when the cows love it, the farmers love it. You have happy cows, you have happy farmers. Here we have the phosphorus removal system, the first and only phosphorus removal system in the state. The digestate material from the digester gets pumped in over here and first goes through a trommel screen, which sources out, separates out contaminants. Then the material gets pumped over to this side to a dissolved air flotation, or DAF system. There's a polymer that gets fed in here and mixes with the dissolved air, and that pushes the phosphorus material to the surface. And that foamy material then gets skimmed off by these skimmers and conveyed out to the other side of that wall into a closed container. Behind me are two 2.5 million gallon effluent storage tanks. So the effluent flows from the phosphorus removal system into these tanks, where it's stored for use by the farmer, the Goodrich Farm. They take it and land apply this low carbon, high strength fertilizer material to their crop fields in accordance with their nutrient management plan and their regenerative agricultural practices. Here we are on the final stop of our tour, the gas upgrader. The biogas from the digester gets fed into the gas upgrader, where we remove contaminants and upgrade the gas to pipeline quality, about 99% or better pure methane. That gas then gets pumped through the Vermont gas pipeline to customers down the line, including Middlebury College. And some renewable natural gas is also available to other Vermont gas customers.